Here's another case. We've got two lists of numbers we're gonna store, and I want to add those numbers together. So you can see based on the numbers, I added 0.1, 0.2, and 0.3 from up there. So what it did, it grabbed these two numbers, added them together, grabbed those two numbers, added them together, added those two numbers, added them together, and returned a list. So that's kind of handy. So again, when you start processing data in lists, it gets to be a lot more efficient. How would that look if we didn't do that? You could do a function like that would work, but who wants to debug that? And again, X and Y, X, Y, Z, there's a limit to that, but a lot of the stuff you may be doing may be with much longer lists, different data types. And again, this is a much shorter form of that. So here's another case. So STR case, if you just pass a string, it converts it one way. But there's an optional T argument, converts it the case the other direction. How do I do that with mapcar? Because mapcar just takes a quoted function. So we're going to load this into memory. Here's my quoted function. Here's my list. Well, I can make another list with those 4 T's, and that T will get passed into that STR case function each time. And now I forced it to lowercase. So like I said, the first time I didn't have any arguments, so I can build a bogus list with those T's to pass as arguments if I want to force that to uppercase and lowercase. If I wanted to make that third one the opposite case, I could change the list that way. You see how that works? It kind of processes those lists in parallel. Again, here's, what if you wanted the seconds per week? We've got a whole lot of code that can calculate that. But this is actually a little bit easier, isn't it? So that gets into, this starts transitioning into combining another function called lambda. Does anyone use that? So everyone defines functions in Lisp if you're writing Lisp code. Lambda defines a function. So when you do a defun and then give it a function name, you can call that in at any time. Lambda, it's like creating a temporary function in memory. And once that's done, you can't call that function anymore. So it's kind of creating a function all in place. So essentially what I'm doing, when I came up here, I created a whole bunch of another list to pass that argument to it. I can do a similar thing down here. There's my list. So I've got my mapcar, but instead of quoting a STR case, I'm quoting this function to it. Does that highlight up there all right? Looks a little goofy on my screen. But this function right there, it's like a defun statement, except it's lambda. And this x is the argument it takes. And what it's going to do is it's going to take each item in this list and call this function and throw that, it's going to throw apple in this x argument. It's going to do just str case apple with the t. Str case orange with the t. So that does the same thing. So now, again, I could type 4 T's, but maybe I don't know how long that list is. Now I've got to write code to add up a number of T's and compile them together. I can use that lambda statement and build a function on the fly because it's doing a lot of advanced stuff, and then mapcar can just call that function when it needs to. Here's another, here's another example. I've got all kinds of syntax in there. And I've got this lambda function. It's going to call that for every item in the list. So what's it going to do? when we call that function. I just extracted out the first 3 characters, and I made sure that the case was, the way I wanted to. I wanted the uppercase first letter, everything else lowercase. So again, mapcar allows me to apply a function to every item in the list, substituting that item every time. Well, what I wanted to do is a little bit more complicated now. I wanted to grab the first character, make sure it's uppercase, grab the second and third character, make sure they're lowercase, combine them together, and that's what this function does. When I pass January to it, makes an uppercase J, lowercase an, spits it out together, kind of holds it in memory, does it with February, November, December, and when it's done, spits the whole thing back out a list. So you can see that can be kind of powerful. So here's another one. This is pretty common, maybe more back in the 2D drafting days. Point 1, point 2. I've got a function. If I want the midpoint, if I want to calculate the midpoint, what do? Add x, add y, add z, divide that result by the x by 2, y by 2, z by 2. So I've got a function in here, takes 2 arguments, and I pass 2 lists to it. So every time this function gets called, the first time it gets called, I'm going to get the 3.24 and the 2.5 thrown in there. And it's going to add them together, divide them by 2. It's going to do that for the y value. When it gets to z, oh wait, there's no z value on the other one. It's going to ignore that then. If you're passing more than one list, it's going to do it just for where there's pairs. So it's going to forget that z component when you run that code. So there's our data set. And that's the midpoint between those 2 points in x and y. No z because that second point I didn't have a z value in there. If I wanted to add a z value in there, let's run that again. What's the halfway between 0 and 1? 0.5. Quick way to calculate the midpoint between 2 points. It was a lot more common in 2D than 3D. A lot of people don't automate as much in 3D, it seems like. But again, that lambda statement really helps with that. You may also see this. So here we've got the quote symbol. Here we don't have the quote symbol, but we've got this function thing thrown in there. So anybody compile any of their Lisp into like a FAS or a VLX file? The FAS is encrypted, compiled, fast load AutoLISP source is what it stands for. VLX can compile that other stuff into there. In certain cases, if you cancel out of your function, when you're using this syntax, some of this source code could be displayed in your command prompt. So if you're really sensitive about people seeing your source code, so this would be more for a commercial developer, use this function, and that keeps that from happening. It was something Autodesk added to cover up that hole in their encryption process. But when you use that lambda statement, if it was in the middle of that and an error happened and your program canceled, it would actually scroll back some of the code on your screen. So that's why that's there, not required. Honestly, I use this. Again, if that's all you saw in a whole program, that's not that helpful, right? So here's another thing I did. I'm trying to remember what this one was for. Let's just run it and see. That's not working. I think I need to point PT1 first. No, you know what? I know what that is. All right. Apparently I don't have my sample drawing. So that's a block. That line is in a block, so a block has an insert point. All of a sudden I seem louder. There's a function called nSLP, which allows me to extract the point from that, oh, that is loud, extracts the point from that line in that nested block. And then it gives it to translate that into the world coordinate system instead, because that block could be scaled, rotated, inserted somewhere else. Because of that, you get this, what they call a transformation matrix. So let me do this again, set Q PT1. It's been a while since I've run this. Yeah. Now let's see if this works. And like I said, I wanted to rehearse this. I got one other option I'm going to try, and then we'll move on if this doesn't work. There's another one, ENTSLP, where it doesn't give you the point. No, I've got an error in there somewhere. Sorry about that, but remember before I was telling you I wrote all this big long code to extract out and run it through this transformation matrix? That's what this was for. And somebody posted back this. And that's the function that ticked me off. I'm gonna figure out what the heck that does. And it took a while. And then after I finally figured out what it does, how did he think of that? That I haven't figured out. But again, it shows you some of the power stuff. It's one of those things, it takes a while to build functions like that. But if you make a modular, you do it once and I never use it again. I just call that function every time I need it. So it's not like you're using some of these advanced functions all the time. All right, so let's move on to recursion. Here's where code calls itself. Is everyone familiar with the mathematical term factorial? You know, the factorial of 4 is 4 times 3 times 2 times 1. The factorial of 3 is 3 times 2 times 1. How would I do something like that in code? On the other hand, I could write a function that does that because I don't necessarily know how many numbers they are, how far it's going to be nested. But you'll see it takes an argument. What number am I getting the factorial of? And well, when I get to 1, I'm done, right? So I have a condition statement that looks for the 1. But if it's not a 1, I call the factorial again. But instead of calling the factorial 4, I subtract 1. Now I'm calling factorial 3. And it runs through, and hey, you know what? To get to that, I need the factorial of 2. And so it keeps on drilling in, and then it works its way back out and returns the function. So this is essentially what this is doing. But I'm giving it a different function name each time. This function calls this function, calls this function, this function, we'll call this one, and does that. That's kind of what's happening behind the scenes, but it's all just wrapped up into one function. I can't type today. Is that right? It's been a long week already. But again, that function calls itself. Now this is where you may end up having to crash out of AutoCAD when you start playing with recursion. If you don't find an out, it's going to loop forever. So you got to build an escape in there somehow. And you'll undoubtedly do that at some point. So that's a good place to, that's one good place for it. Where I find to use a recursion more often is like with lists that may have nested lists. The best example I can think of is think of your folder structure on your computer. Give me the directory list under the C drive. Here's a bunch of directories. Some might be the only directories. Some may have subdirectories. How do I get them? If I want to return everything, anytime I find a subdirectory, I've got to look at the list again. Well, some of those may. So now I don't know how far nested that is. That's where recursion can come into play. So I wrote a function here. I want to determine if a particular item is in a list. But look at my list. It's got varying nesting levels, right? So how am I going to find out if 9 is a member of that list? So here there's another function, VLSum. Again, you can look up. Just like mapcar, it calls this lambda statement. I can use lambda with apply. It probably doesn't really work there as well. But you'll see at VLSum, a lot of the VL statements will take it. Mapcar, it's a good place for it. But what this is going to do, it's going to look, and it's going to call the function again. It's going to look, and if it sees a list, it's going to call itself again to work on the items in that nested list. And if it finds another nested list, it's going to work its way in again. So let's load this function up. Item in list. What do we want to do? We want to pass it my list, and I want to look for 10. What if I do 17? So again, this is similar to mapcar. Again, go to the LISP, the LISP help file. That'll tell you what some of that stuff does. But again, you can use that in combination. Quite often you'll see lambda used with these other functions. But that's going through, and every time it finds a list, it just calls itself again and passes that smaller list to it. And it kind of keeps track of all that stuff in memory and assembles it at the end and spits out the information. This one is nice. The guy that showed me that nice little short code came up with this as well. Who's here in manufacturing? So pretty common to see on the title block of a part drawing, revision A, B, C. What if I wanted code to automatically increment that? What if it's an A? I want it to go to B. What if it's B? I want it to go to C. Here's a nice little function that does that. So if I don't pass it an empty string, it starts out at A. But now I could say I want to extract the revision of my drawing. I call this function. I give it a B, and it's a C. What happens when it's Z? It becomes AA. Now that's one of those things, if you want to really understand how recursion works, I would take this function in particular and dissect it. And again, this is one of those things in Lisp. I could actually create a breakpoint up there. I don't know how many people, a lot of people use the Visual Lisp editor in here and use the error checking and stepping through code. I'm going to reload that into memory, and I'm going to call that. And now I can actually step through that code little by little. And one of the things I could do, I can inspect that value. But what I can do, I can right-click on it and add a watch. Let me get rid of this old value. Add that to the watch. Add that. And then as we step through, you can kind of watch how some of those values are being filled out. And it's going to keep looping through. But you can kind of watch what some of that stuff is doing as it's looping through, watching how the variables change, what it's doing. The trouble with the recursion is once it calls itself, all that other stuff kind of gets put on hold, and now you're looking at when it's being called at this particular point in time. Select the text, right-click, add watch. And it'll add it to this little watch list. And then this will add the breakpoint. Sometimes I've had things where they loop a lot. I want to make sure they get to a certain point. I can add multiple breakpoints. And then as it's stepping through, I got to reload that code. I must have typed something wrong here. There we go. Now when I reload that code, I stopped at that first breakpoint. And let's say there's a big loop in there. I just want to make sure I got that far before my code errored out. You know, I could actually say continue, and then I don't have to step through anymore, but it's going to stop at the next breakpoint. So I can put multiple breakpoints. That's what I'll do a lot of times. And okay, yeah, I watched it loop a couple times. I got it, it's working. I don't need to watch the other 1,000 iterations and click all the time. Tell it to continue, then it'll go to the next breakpoint. Again, those are some of the things that can be really helpful in AutoLISP. Years ago, it should be online somewhere, I did a lab on how to use the Visual Lisp editor to debug code that you didn't write and have no clue how it works. I took a sample program from Autodesk, injected some errors in it, and I walked the whole lab through. Here's how you use the tools in Visual Lisp to find and fix those errors when I have no clue what that code does. So if you're interested in learning more about the Visual Lisp editor, you might want to look for that. I could send it to you as well if you guys email me afterward. But that's it kind of for some of the advanced functions. I am going a little bit slow. Recursive programming, we've covered that. All right, Visual Lisp primer. Why should you get into Visual Lisp? There's a whole bunch, a bunch more functions in there. There's over 2,000 Lisp functions that aren't documented anywhere that are based on Visual Basic code. My apologies, I didn't get, VBA kind of went away and Microsoft said we're not going to support it. And so Autodesk pulled it out of the core products and then, well, it's still living on, so they had an add-in. If you search, they still have it. It's been years now. You can add the VBA module to AutoCAD. You can get it from their website, from Autodesk's website. That'll add a help file that will actually go through and document the Visual Basic object model, which is the good way to figure out how to call the Lisp code by looking what Visual Basic does. Let's dive into reactors here quick. I probably should have canceled out of that. Here we go, open reactors. So, reactors are code that runs when certain things happen. You're going to have to look up in the Lisp manual to find out there's reactions and reactors. So, one of the reactors is like save. Then there's there's a reaction, there's a pre-save or a post-save. Do I want to run my code before I save or after I save? Those are the types of things you got to look at. There's I forgot back in the manual in the handout here. Event triggers, those are the types of, the reactor functions help build that infrastructure of code. The different types of reactor types, whether pre-plot, post-plot, entity deleted. You could write a program that every time somebody deletes an entity, it doesn't undo. So your object just keeps coming back. Or, you could, so you got to get kind of creative about what you could do. So with reactors, I've got some helper functions, and it's above what I've got time to get in that class. But down here, I've got some helper functions that I've written. There's what's called, I should just keep sitting. That gets louder when I stand up, at least to me. There's what's called persistent and transient reactors. By default, it's when you create a reactor, it's transient. Persistent reactor gets added to your drawing and it stays there forever. A transient reactor has to be loaded every time you open that drawing or it won't run. So to give you an example, essentially what you're doing, you're configuring your drawing to call code that executes when that reactor's run. So when I open my drawing, it has no reactors in it if they're transient. Everything it did the last time I opened it is gone. It is up to me with like acad.doc.lsp or acad.lsp or an MNL file or somebody manually initiating loading code. It's up to me to load the code to create the reactor so that reactor's then in the drawing. It's also up to me to load the code that gets called when that reactor fires. It's up to me to do that. Now, a persistent reactor, once I load that and configure the drawing, I save it and I go back, I don't have to load that reactor anymore. It stays in the drawing, but I do have to have the code loaded that it calls. It doesn't store the function that you want to call. It just kind of configures and says, hey, this is the function I'm calling. Remember that, and it assumes it's there. So you'll get some errors if you don't. So I've got some helper functions. What happens if I load a reactor, and then I tell it to load the reactor again? Now I've configured it multiple times. So that event I want to happen may happen multiple times. I've got a little function here that I wrote. It just checks to see if the reactor, my save reactor is loaded or not. So before I load it, I want to make sure it's not already loaded. But it may be loaded, and I may have two different save reactors. One calls this code, and one calls that code for some reason. So I've got another helpful function down here. I want to make sure that that function callback is the same. So before I configure a save reactor to call my test program, is there a save reactor already? There is. Is it calling the test program? No? Okay, then I'll load it. So those are little helper functions. Like I said, I wrote them once, figured it out. I couldn't tell you how they work anymore. I just used them. Yes? You would have, so could you create a transient reactor that goes away after a certain amount of time? Yes, I haven't written any code to unload manually, but you would probably want to unload it then, not just rely on the drawing being closed and then reopened.
So it has to be, the code actually has to be unloaded. It can't be like a function that's
In a sense, the code isn't loaded, but what you're adding in the drawing is saying, look for this and run this function. That's what you would have to unload, I think. Or you would have to build in some other mechanism that, there's a temp file on disk that, hey, when that's there, I know this time has elapsed, or I shouldn't run again. There's a lot of tricks you could do to work around those types of things. So I've loaded all this code here, and I've got a couple functions. And essentially what I'm going to do, here's my drawing reactor. There's different types of reactors. And this is just a helpful little comment, so if you're ever debugging your code or looking at stuff, you can actually see at the code level, a little note what that is. And I want to run this function before I save. And again, here's my function. If this function isn't loaded, it's going to try to call this function even though that's not loaded. It's up to me to make sure that's loaded. And I also have a save complete. And I'm going to run that function. So like I said, I loaded all of these things. And this is the function I want to load. I'll copy and paste because we all know I can't type today. There we go. We'll just save it there. Now, it asked me for the file name, but it didn't save it yet. It called my code that says, hey, this drawing is about to be saved by me. I click OK. It saves it, and now when it's done being saved, I get this message. Now, you'll notice this function, this is what actually created that reactor environment. I've got code that I want to run that says, hey, be pre-save, post-save. That created that environment. And I set up this reactor with it. So if I run this function again, you don't see my little helper functions in here, do you, anywhere? It's just going to say, hey, when the drawing is saved, run this code before and after. So I'm going to run my function again. And now let's do another qsave. I can't even type qsave. Drawing is about to be saved by me. Drawing has been saved by me. Actually, you know what? Oh, I know what I did. Because I loaded that whole form, it grabbed that second one. Let me do this. Let me start a new drawing. And we're going to load I have the same function in there twice because as I work through it, I want to load another variant for you. And I loaded that, so that overrode my first function up here. There we go. So this is the function I want to call. That loaded my reactors. I type qsave. It's going to ask me for file name. Pre-save, post-save. If I run my function again, I'm going to qsave, pre-save, pre-save, post-save, post-save. So that's what you have to be careful with on the reactors. Every time I run this function to load that reactor, it just keeps adding it on. And now, every time my drawing's saved, it runs this twice. If I ran this a third time, it would run this 3 times. That's why I built those helper functions. Here's a little bit different variant, and you'll see what I'm doing with that. I'm calling to see if that function is already loaded or not. And if it's loaded, I want to make sure that I'm also checking maybe somebody has a couple different save reactors. I want to put something in one database, and I've got code that pushes something to another database. I may have 2 save reactors, and that's fine. What I don't want to have is 2 save reactors that call the same exact function. So it checks to see if the reactor's there, and it checks to see if the function that reactor's calling is the same one you want to add before it does that. So now when I load this code, and again, those reactors are already loaded, and because they're persistent, I want to actually start a new drawing. Or actually, I could do this. There's the drawing I just saved. You notice the reactors don't run. They're transient, even though I open that drawing back up. So now what I want to do, I want to load that code. I know what I forgot my helper functions. There we go. There, now my reactor is loaded, qsave, and I'm asked before and after I'm saved, I get that little prompt. I'm going to load my code again. In fact, I'm going to load it multiple times. It asks me once before and once after. So that's what those little helper functions do. So like I said, they just make sure, like I said, I figured out how to do that once. I've never done it again. I would have to really dissect that. Now, if you do want a transient reactor, or a persistent reactor, you don't need these functions anymore once it's initially loaded. I don't have to load this every time I open my drawing. I just have to make sure these functions are loaded and available. On a transient reactor, every time I open my drawing, all of the rest of this code needs to be there in place. Does that make sense? So I haven't really found what if you give your drawing to somebody else? It's going to try to call your function that they don't have. So there's probably less cases to do a persistent reactor. By default, they're transient. There's some functions that actually convert that reactor to persistent, so it stays in your drawing. But if I've got to load, if I've got to load these anyway, why not just load and run those? This other stuff. You know what I mean? That's the way I look at it. If I could just define it and I never have to load any code and the code's embedded in and it knew what to do, I could buy the persistent reactor in that case. But being that I still have to load code, I don't bother with it. Did anyone got any questions on that?
That's all in the handout?
Yeah, more or less. I don't know. I tend to get a little bit verbose sometimes, and I'd probably be better with simpler, less wordy examples. Back in the day, they wanted good, get rated on your handouts, and I'd spend hours putting a 70-page handout together, and somebody ding me on my handout, and it's like, screw you guys, man. So I just, I kind of wing it. So that's an old handout. That's why it's still long. But like I said, I try to provide my information. A lot of it's just about getting ideas, knowing what's possible, and I'm available to, now I won't write all your code for you, but I'll give you pointers. I might, find a couple errors or something. Just let me know. You had a question back there?
Yeah, I think it's a little unclear on the concept of
Yes.
Is there, are you talking about having, I guess I'm unclear on how, like, does AutoLISP functions and variables stay in a drawing?
Mm.
Is there a context in which they actually stay with the drawing?
No, not that I'm aware of. I mean, VBA, I believe you can embed code in the drawing, but not LISP. He's asking if there's a context where the LISP will always stay loaded, and that's not the case. You know, what stays with the drawing is it configured, when it sees this code, it knows, the only thing it knows is the function name, and then it should call it for whatever reaction, you know, you've defined it for. So it knows the function name, but it doesn't have any of that code. You always have to load that code.
That's like in a dictionary or something?
Yeah, somewhere. I can't say I'm an expert on where it stores all that stuff. It seems to keep getting more and more complicated, but yeah, it's in there somewhere, and there's functions that extract that out, and that's why I wrote those kind of helper functions. Like I said, you know, so now I don't have to figure out every time I write one, I have to go through all that work of figuring out is it loaded or not. I just try to make reusable pieces of code like that and then reference them. So that's, you'll find that a lot when you start doing the advanced functions. You'll do something really wild and crazy, make it modular so you never have to dig into the thing again. So that's pretty much it for reactors. Yeah, so I kind of walk you through some of the stuff. You know, like I said, the helper functions, if you want to kind of understand what they do, try to write one yourself, you know, from scratch. That's a good way to learn too. You know, okay, well, God, if I ran that function twice, it loaded my code twice. You know, maybe if you're loading the reactor from an ACAD.LSP and you know that's never going to get run again in the same drawing, you don't have to look for it if you're confident your code won't run, but I like to make sure double check. So how do I keep it from loading twice? Try to write that helper function yourself and you'll get a good understanding of the reactors. All right, so ActiveX. So that's like all the stuff you can do with Visual Basic, I can access from Lisp. Now when you it took me a while to find this and update the image, but if you install the VBA add-on to AutoCAD 2018, if you look in this, you'll see this file will get added, and that's the help file. And this will show you kind of how they structure kind of an object model. I can't get to the line until I go through paper space or model space. It's in one of those two places. You know, so this is, you can click on any of those things, it'll take you in and tell you that the line has a length property. So instead of me calculating out a length, doing it through kind of the Visual Basic style, I can just get the length out of it. I don't have to calculate it. That's a property. A circle has an area property, a circumference property, things like that. There's a lot of benefits to using some of the Visual Basic style stuff. Now, you don't have to, somebody email me and yell at me if I'm wrong, but you can call the Visual Basic style stuff, the VLA functions in Lisp without adding the Visual Basic add-on to AutoCAD. That stuff still works. The reason to add that Visual Basic stuff on there is to get the documentation. You know, and like I said, there's a couple thousand functions that aren't documented anywhere. How do I know what they are? You know, so unless you've been doing it a while, that's how you have to kind of get that information. You know, so they go through and there's some syntax things. I kind of explained it a little bit more in the handout, but you know, maybe you pass an argument in a different order when you call it from Lisp. The handout will go through a lot of that, you know, how to navigate around and do some of those things. I should have some sample code here that we can do. So the first thing you need to do to call any of those functions, hopefully I haven't loaded it already. VLAX functions are in there, but none of these VLA functions will work until you call VLLoadCom. And that loads all the COM automation stuff into Visual Lisp for you. You can call this function multiple times. It doesn't do anything more. It just needs to be called once. So if you're going to use any of these VLA functions, it's customary just to throw that at the beginning of the code. Make sure it's loaded, otherwise it doesn't know what this function is. So I'm going to draw something here, just a simple line. I'm going to load that code. I'm going to grab that line object. You guys are familiar with that, I'm sure, if you're doing Lisp stuff. There's an entity name. I can convert that entity name at this point to a visual, an ActiveX object using this function. So it's kind of like an entity name, but it's the ActiveX version of that. And now from that, I've got a function called getLength. There's the length of that line. I don't need to, so all this map car stuff I showed you and how you can add, coordinates together and, you don't need any of that stuff. You can just do this. So, so that type of thing is pretty easy. It's, you can it gets a little bit harder, some of the other things you do. So what if I selected a circle when I did that? My Alt-Tab keeps not wanting to stay focused here. I'm going to run that. I'm going to select a circle. I'm going to run this code. That gets my object. And I've got an error. There is no length property. So here's how I handle that. There's another function, the VLAX. Is the property available? And then I quote the property. And again, when you go to, let me get back up here. When you start digging into this help file, you'll see what they call properties. So you'll see what the property names are. Go to line, see what properties are available. So now you know the syntax. Come through here, you quote the property you're looking for. If that property is available, it's going to run, extract that, or pop up a message, no line selected. And if I run it again, come on, Alt-Tab. Nothing selected. What is? Oh, there we go. Because I'm doing my code piecemeal. Glad somebody's paying attention. That's good. I did that on purpose. There we go. Now it returns it when it's a line. So now there's other things. So there's, getting a property. And so kind of the key is, for every property you see, there's a get. VLA, get, property, and then the object I'm looking for, the property on. So that's kind of the syntax. When I come over to and start looking at things there, and I see the property I'm looking for, how do I figure out what those VLA functions are? Well, if I want to extract the property, there's a get and a property name. So for a circle, there'd probably be a circumference or an area, things like that. That's the way to, one way to do that. Now let's set the layer. Looks like I need a layer called wall. Created in my drawing. Come on. All right. Again, I always load to make sure it's there, but it's already done. I don't need to run that again. You know what? Let me make that layer a different color so it jumps out at us. Come on. Alt-Tab is not my friend today. I converted that to an ActiveX object. Now, you guys are probably, if you've done object manipulation in Lisp, you gotta extract the DXF file, pull out the association code, swap out stuff, reconstitute my list, do an entity update. To get all that stuff done, it's a lot of work. Sometimes it's a little bit quicker with this methodology. So one, it's going to look to make sure that there's a property called layer. I can't set the layer on something that doesn't have a layer property. And is it a read-only property, or can I write to it? If it's a read-only property, I can't set it again. There's a lot of read-only properties. So there's another function in there. And so now, just like there's a get, there's also a put. Object I'm putting it to, or the object I want to add the property to, and then the property. So when I run this, that should work. And now my line's green. So is that a little bit easier than going through some of those, extracting out all that DXF stuff? There's advantages. I'll jump back and forth, between those two different methods quite often. Could that be applied to all tool space? I don't know that I'm understanding.
Objects within model space, or within your paper space or model space right now, could that be applied to settings that are all pulling certain layers or settings, that style?
Yeah, Visual Basic has a way of doing that stuff. There's probably ways to get to that stuff from LISP. I'm not as familiar with doing some of that, but there's in the object model. There's a most of the stuff you're going to deal with. You'd have to look through. So in the object model, you'll see up here a little bit, there's a preferences. So when you go to options and all that stuff, there's ways to access that with Lisp. The problem is I can't just go grab it and name, convert it to an ActiveX name and dig right in. Some of that stuff I have to kind of start at the document object level and work my way down to get to it. It's not quite as easy. Entcell or SS gets pretty easy and quick in Lisp, so I can get to write what I want instead of navigating all the way down. Kind of running out of time here. Here's one where we add line out of, add line, get model space object, And so it's kind of walking you through how to do those different things. There's additional files that you can get, and there's an ActiveX.Lisp as part of that that's got these things. So it kind of walks through, here's what I'm doing. I'm getting the model space object and layers as needed. I want to add the line, but we've got points. Points are a little bit different. There's like safe arrays and things like that. So you don't necessarily pass a list. Just like an entity name doesn't work with the ActiveX, there's an ActiveX object name I got to convert to. I can't just pass a list to things. I've got to convert like my list of coordinates to what they call a safe array. And you'll see some of the stuff here. So when some of the parameters are, if I'm going to add a line, there's a start point. Let's try to find the function. Add line. There's a function called add line. So same thing in that ActiveX the VBA documentation. There's properties. There's also there's also functions. There's a function called add line. Here's how you would call that. There's an add line, add circle, and it'll tell you what objects it needs. It needs the model space object, and it needs a start and an end point, and they have to be what's in a safe array. So like I said, you have to walk through it. You go through the handout, it'll kind of walk you through some of that. So passing things like points gets a little bit more complicated than Lisp sometimes. So it's kind of up to you how you want to approach that. But dig in and try some of the code. And like I said, the main thing is just trying to understand when I see that Visual Basic syntax in the help file, how do I convert that to Lisp? And just remember, if it's a property, I can get or put any property. There's a VLA function for it. And then for adding the functions in Visual Basic, there's an add line function. You just prefix that function with the name VLA dash, and then you've got to figure out what objects it's passing to. I've got to get a model space object, not from a Lisp standpoint, from an ActiveX standpoint. I need to pass a start and end point, and those aren't lists anymore. They're a different object type in ActiveX, and I can convert a list back and forth. There's different ways to build that, but that's kind of how you come up with the syntax. But we're kind of bumping up on the time limit here. Like I said, hopefully it's enough to get your mind thinking about things you might want to do. I said, you got any ideas or questions, or didn't understand something? I've got a stack of cards up here. Feel free to grab them. Email me anytime, and sometimes I'm a little slow to respond, but I usually always do respond. And I'm glad to help you out whenever I can. But thanks for coming.